Welcome to the Greek Ship Corrosion channel. My name is احتشام زاده. I'm a researcher in the field of corrosion and protection of materials. Chapter 2, Section 4, Thermodynamics of Electrochemical Reactions. General cell reaction, dynamic equilibrium, cell representation, electrochemical cell convention and terminology. The main reference is Fundamentals of Electrochemical Corrosion, ASM International. The generalized cell reaction is useful to establish a generalized representation for the electrochemical cell reaction as follows: X moles of M plus M moles of XX plus double arrow X mole of MM plus M mole of X, which is the sum of the following half cell reactions: X mole of M double arrow X mole of MM plus X times M electrons, M moles of XX plus X times M electrons double arrow M moles of X. The double arrow implies that the reaction is going in both directions, either left to right or right to left. The double arrow indicates a reversible reaction. A double arrow is used when both the forward and the reverse reactions occur simultaneously, indicating a state of dynamic equilibrium. What is dynamic equilibrium? Equilibrium is attained when the sum of chemical potentials of the species on the left-hand side of the equilibrium expression is equal to the sum of chemical potentials of the species on the right-hand side. At the same time, the rates of forward and backward reactions are equal to each other. Dynamic equilibrium only occurs in reversible reactions, and it's when the rate of the forward reaction is equal to the rate of the reverse reaction. These equations are dynamic because the forward and reverse reactions are still occurring, but the two rates are equal and unchanging, so they're also at equilibrium. Cell representation. The abbreviated cell representation for the generalized reaction is shown as the follows: left-hand electrode, M yields MM plus M electrons. Right-hand electrode, XX plus X electrons yields X. The anode, left-hand electrode, and cathode, right-hand electrode of the cell are separated by using two bars or slashes that represents a salt bridge that connects the two electrodes. Here is the salt bridge. If the reaction of XM plus MXX plus reacts to yield XMM plus MX occurs spontaneously from left to right, then the Gibbs free energy change of the reaction is less than zero. In this condition, if the electrochemical cell reaction is allowed to occur, the electrons' flow and conventional current flow direction will be as shown in the figure. In general form, delta G reaction equals negative N times F times Ecell, where delta G reaction is the Gibbs free energy change for a finite amount of reaction at constant temperature and pressure. N is the number of moles of unit charges or electrons transferred per unit of reaction. F is Faraday's constant, and Ecell is the potential difference between the electrodes. Ecell equals E RHE minus ELHE. Summary of electrochemical cell conventions, terminology, and relationships. Cell reaction XM plus MXX plus reacts to yield XMM plus MX. Cell representation MM plus the activity of MM plus, two bars that shows salt bridge, XX plus, activity of XX plus X. Electrode identification. LHE, RHE. Electrode potential E prime M M M plus E prime X X X plus. Cell potential Ecell equals E prime RHE minus E prime LHE. E general case of potential E prime potential in the case of no current passing, that is at equilibrium. If reaction is spontaneous from left to right, Gibbs free energy change of the reaction is less than 0, which results in electrode designation anode cathode. Anode is LHE, cathode is RHE. Terminal polarity anode is negative, cathode is positive. Electrode reaction oxidation occurs on anode, reduction occurs on cathode. Current flow I, electron flow E. In the elementary electrochemical corrosion circuit, current flow, electron flow are shown. The video titled Chapter 1 Section 4 Corrosion Circuit is available on this channel. Challenge number 14. Thank you for your time. If you like to challenge yourself, please answer this question in the comments below. Lead is used as a construction material to contain sulfuric acid because of the formation of an adherent coating of lead sulfate. For the corrosion of lead in 1 molar sulfuric acid, A. Write cell reaction and cell representation. B. Calculate the driving potential Ecell when pH is negative 0.3, sulfate activity is equal to 1, and the solubility product constant for lead sulfate equals 1.3 times 10 to the negative power of 8.